Chapter 9 is about graphing functions and all different types of functions, as you're going to see. So for section 9.1, it's a review of operations and composition for functions, and we first introduced these concepts in section 4.3, but we're going to go over them again and dive a little bit deeper. So here are the four operations on functions. If I have two functions, f and g, right? Remember, to be a function, you have to pass the vertical line test. So each x has exactly one y. Then I can go ahead and add those functions. So I can take f plus g of x, which is our sum function, f minus g of x, which is our difference, f times g, which is our product function, sometimes also denoted f g of x, and our quotient function, which is f divided by g. So let's work through a few examples. So given two functions, f and g, let's go ahead and find their sum function. So I have f of x is x squared plus 1, and g of x is 3x plus 5. So I'm going to have f plus g of x, which is f of x plus g of x. So I have x squared plus 1 plus 3x plus 5. So I get x squared plus 3x plus 6, because we're combining like terms. Then in order to find f plus g of x, there's two ways we could do that. So one way is we could plug 2 into our equation that we found for f plus g of x. The other way is we could take f of 2 plus g of 2. Let's go ahead and do it that way. So f of 2 would be 2 squared plus 1 plus g of 2 would be 3 times 2 plus 5. So I get 5, because 2 squared plus 1 is 5, plus 6 plus 5, which is 11. So my answer is going to be 16. We can also find the difference function. So given these two functions, f of x is x squared plus 1, right? That looks like a parabola. G of x is 3x plus 5. That's a line, the graphical line. We can take their difference. So I'm going to take f of x minus g of x, and that's going to give us x squared plus 1 minus 3x plus 5. And remember, I'm going to have to distribute that negative. So I have x squared plus 1 minus 3x minus 5. I get x squared minus 3x minus 4 is our new function. And in order to find f minus g of 1, I'm going to take f of 1 minus g of 1. Or I could have substituted 1 into our function that we found for f minus g of x. I'm not going to do that in this case, but that is another way you could solve this problem. So this would give me 1 squared plus 1 minus 3 times 1 plus 5. So 1 squared is 1 plus 1 is 2 minus 3 times 1 is 3 plus 5 is 8. 2 minus 8 is negative 6. So now let's talk about domain and range. You've heard me use those terms a lot. I've even defined them before, but I'm going to define them again. So the domain of a function is the set of all possible values of x. And the range of a function is the set of all possible values of y. When I have my functions, the sum function, difference function, product, and quotient function, the following holds true. So for the domains of f plus g, f minus g, so the sum function, and the product function, includes all real numbers at the intersection of the domains of f and g. Intersection, that means where they overlap. The domain of f divided by g, or our quotient function, includes all those real numbers in the intersections of the domains. So we're still taking the intersection, but we've got to make sure our denominator never equals 0, right? This gives us a rational function. So we treat it like a rational function, which we have graphed before. So if I have f of x is 3x plus 4 and g of x is x squared minus 3, for each of the following, I just want to give their domains. So f of x is a linear function, and linear functions have domains from negative infinity to positive infinity. So the whole number line. G of x is x squared minus 3. So it has a domain of negative infinity to positive infinity as well, right? Its graph looks like a parabola. It's a parabola that's been shifted down 3, which means its range goes from negative 3 to infinity. Well, what's the range of our first function? I didn't state that. We're going to give our domains and ranges. So our domain of 3x plus 4, actually we're just going to be giving our domains, but it's good to state the ranges. So for f plus g, where do our domains overlap? Well, that's everywhere. The same is true for f minus g, as both their domains are all real numbers or negative infinity to infinity. What about for the product? Well, again, we're taking the intersection. So I have from negative infinity to positive infinity. Now when it comes to f of g, this would give us 3x plus 4 over x squared minus 3. So it would be the intersection of the domains, which would be negative infinity to positive infinity, except my denominator can never equal 0. So we would need to solve for when my denominator equals 0. So it would be all real numbers as long as x doesn't equal plus or minus the square root of 3. Those are the only two values not included in this new domain.